We're going to describe motion, how things are going to be moving. We need some quantities to measure, to be able to describe. Now, what are those quantities going to be? Well, clearly one of them will be position. Whereabouts is the object? Now, that's going to be a vector quantity. Again, not surprisingly from last topic, we're going to be using quite a few vector quantities. So where is something in terms of how far away it is and in what direction? Now, there's another quantity we've already talked about a little bit, and that is how fast it's changing where it is. The velocity. And remember, this isn't just how fast it's moving, but in what direction it's moving. So in fact, we'll call velocity the change in position divided by the change in time that it took. And we can do this symbolically. If we write down here for velocity the symbol v, and we'll give it a little arrow on the top because it's a vector quantity, it's going to be equal to, as it says, the change in position, and we'll use a triangle delta, we call that, delta x, the change in position x, divided by the change in time, and again we'll write a delta and then t for time. There's our velocity, the change in position divided by change in time. And let's just remember what we mean by the change in a quantity. It's the final value, so here's our final position, minus the initial value. So there's our initial position, divided by the final time minus the initial time. That's the change in time. Now this is in fact the average velocity over some period, delta t. So let's go back to our velocity here and write that that's an average velocity, average. If we want the instantaneous velocity at any point, then we simply need to take, our velocity at some particular time. So we'll take our velocity here as being the limit as this time interval, delta t, becomes vanishingly small, as delta t goes to 0, of our change in position divided by our change in time. Now, if you know some calculus, some of you may know some calculus from your maths courses, then you'll know this is the definition of the derivative. This is the derivative of position with respect to time, dx by dt. But either way, what this is really telling us is that the velocity will be the slope of a line if we draw a position versus time graph. And the units we're going to be using here will be the units of position divided by the units of time. So not surprisingly, we'll be doing our velocities in units of meters per second. So let's imagine we're getting in our car, driving to the pizza shop to pick up a pizza, and then coming back home again. How would that look on a graph of position versus time? Well, let's make our vertical axis here our position, and our horizontal axis time. So we're going to start from the start here where our home is at the origin. We're going to zip off to the pizza shop, and then we're going to come back home again. There's our journey on the position versus time graph. Now remember that our velocity is the slope of the line on the position versus time graph. And so we can see for the first part of our journey, we have a slope that is in fact positive. Our velocity is positive. We're heading in the positive direction. We're moving away from the origin towards the pizza shop. The second part of the journey, it has a negative slope. And so the velocity for this part of the journey will in fact be less than 0. Although we're further out from our home in the positive direction, we're moving towards the negative direction, back towards 0. So our velocities change on the way out and on the way back, positive and negative. But what about the average velocity for the entire journey? Well, remember, our average velocity has to do with our change in displacement divided by change in time. What's the change in displacement for the entire journey? Well, we started from home and we ended up back at home again. So in fact, we haven't gone anywhere, even though it took some time. So our average velocity for the entire journey turns out to be 0. We didn't go anywhere in that particular period of time. So we can see here that our instantaneous velocity and our average velocity are really quite different quantities. We changed our velocity during the journey. Now what we're going to do in the next topic is see how can we describe that change in velocity. It turns out it's a quantity that we call acceleration, and we'll be dealing with that in the next topic.